Hi class. So when I chose the chemistry of venom as the topic for my video, I thought, what better way to teach the class about venom than to actually show someone getting bit by a venomous animal? So I flew down to Africa and found a black mamba, one of the most venomous snakes in the world. I smuggled it back to Canada, and here I am now. Now first of all, there's a difference between poison and venom. Poison causes harm to the victims when swallowed, and venom is injected into the victim to cause harm. Most venoms fall into two main categories: hemotoxins, which attack the blood and organs, and neurotoxins, which attack the nervous system. The venom of the black mamba consists mainly of two kinds of neurotoxins: dendrotoxins and fasciculins, which I will discuss later. Now, I've planted the snake over here, where hopefully it will attack my brother or someone else when they come downstairs to watch TV. I guess it's time to wait and see what happens. I think someone's coming. Nice. Let's get rid of this. Now, some of the symptoms that the neurotoxins in this venom are going to cause include tingling, drowsiness, loss of motorized coordination, paralysis, muscular seizure, difficulty breathing, and loss of consciousness, and finally, death by asphyxiation. Before I can explain how the neurotoxins in the venom work, I'm going to go over a really basic summary of how neurons normally send signals to each other through chemical synapses. First, a depolarizing current is created in the nerve cell by the exchange of ions across the cell membrane. The current travels to the end of the cell, which is called the cell terminus. When it reaches the cell terminus, it causes the neurotransmitter to be released and travel to the receptors on the other neuron. For some chemical synapses, the transmitter used is called acetylcholine. Once the signal is transferred to the other neuron, the synapse must be ended. Potassium channels open in the first neuron, releasing potassium plus ions. The release of positive charge repolarizes the nerve cell, stopping the release of acetylcholine. The second nerve cell releases an enzyme that destroys the transmitter. In this case, it is called acetylcholine esterase. This enzyme destroys the acetylcholine at the neurotransmitter receptors to end the stimulation of the second nerve. The dendrotoxins and fasciculins in the black mamba's venom work together to cause muscle spasms and paralysis in the victim. The main component of the black mamba's venom is dendrotoxin. They function by obstructing the potassium channel so that the neuron cannot repolarize after the synapse. This results in the over-release of neurotransmitters, which can lead to convulsive symptoms, which I think my brother is experiencing right now. Scientists have a theory, although it isn't proven, about how dendrotoxins block the potassium channels. A chain of about 57 to 60 amino acids make up dendrotoxins. Dendrotoxins are polar substances because most of the positively charged amino acid residues are located in one area of the protein. These residues are lysine and arginine. Potassium channels are believed to have a group of negative charges at the opening to conduct the positive potassium ions through. The cationic domain on the side of the dendrotoxin can therefore bind to the negative charges at the potassium channel openings. This obstructs the potassium ions from rushing out of the nerve cell, which prevents repolarization, which causes too many neurotransmitters to be released, which causes overstimulation of the next neuron, which results in muscular seizure and paralysis. Because dendrotoxins affect potassium channels, they can only attack neurons that use potassium channels. Fasciculins function in a way that complements the effect of dendrotoxins and amplifies the symptoms. Instead of attacking the potassium channels, fasciculins target acetylcholine esterase, the enzyme that destroys acetylcholine. Humans have developed some chemical warfare agents that attack acetylcholine esterase in a similar way to fasciculins. Sarin, one of these chemical weapons, prevents acetylcholine esterases from performing their function through this reaction. The sarin replaces the hydrogen of the acetylcholine esterase. In this new form, the enzyme can no longer perform its function of destroying the neurotransmitter acetylcholine. Since acetylcholine cannot be broken down, it stays in the receptors, overstimulating the muscle and causing spasms. This amplifies the paralysis that dendrotoxins cause in any neuron that uses acetylcholine as a neurotransmitter. Now that I have told you how the neurotoxins in the black mamba's venom chemically attack the nerve cells in the body to cause symptoms of paralysis, I'll just get out the antivenom to prevent it from killing my brother. Oh, forgot the antivenom.